Here we are looking at an extended version of relative refractive index known as refractive index, if not absolute refractive index. Here we have the first medium and the second medium. The same set of ideas. We have the light moving from one medium into another medium. So the only difference here is the first medium has to be air, if not vacuum. This is fixed. The second medium can be anything. That's it. There's no difference. Everything else remains the same. When it comes to representation, we have the same n. So let me call this as medium x. It's easy to write. Medium x, comma, air. So relative refractive index of medium x with respect to air. Or we can just write it as relative refractive index or refractive index of x. Absolute refractive index of x. They mean the same. This blank space means that the first medium is air. It has to be air, if not vacuum. Right? If you guys are not, I'm sure you understood now, but I'm still, for my own sake, for my own satisfaction, I'm going to explain it this way also. It's similar to writing square root of 100, which means the same as root of 100. Both of them give the same answer, it's just that the representation is different. So similarly, you can write it this way or this way, they mean the same. When it comes to formula, it remains the same. We have velocity of light in air divided by velocity of light in medium x. Again, there's a small change in representation. Velocity of light in air is represented by c divided by velocity of light in x, which is also equal to 3 into 10 to the power of 8 by velocity of light in x. So please remember, this is a fixed value. So speed of light in vacuum, if not air, is approximately equal to 3 into 10 to the power of 8 meter per second. So this is a value which you have to remember. Again, there's no huge difference. It remains the same. And sine of I by sine of r will not change. This remains the same. Okay, so generally the light will bend like this. This is not possible. Yeah. Okay, so you can see it's not a huge difference, just small things that has been changed. So let me introduce you to the definition. So definition is like this. If the medium 1 is vacuum, if not air, then the refractive index of medium 2 is considered with respect to vacuum. That makes sense. This is called as absolute refractive index of that medium. Okay. So why do we need it? What is the point of doing this? Since we are not looking at a huge difference, so why do we need this? It's basically for standardization. Okay, standardization of materials. Right? How we talk about melting point of a given material, wherein we take a 1 by 1 cubed substance and melt it. And we're talking about melting point of that. Right? So we standardize, you can't just take any material and melt it anyhow. Everything has to be standardized. Right? Physics is about standardizing, it's about communicating, it's about understanding nature. So we need to standardize things. So we need to talk about the refractivity of a material. Right? How much does it refract? It is used for optical fibering. Right? So all the internet that you guys are using, that I am using, pretty much everyone in the world is using, is based on optical fibers. That's the main thing that is running around the world. So that is based on your refractive indexes. Okay. So it's a very powerful thing. It's not just a small thing. The topic which you're learning is applicable to the very internet that we are using. Right. So if we happen to look at a refractive index of ice being equal to 1.31, what does that mean? So first thing is, we are looking at an ice, right? Of course, it can be shaped anyhow and anything. And we have a flash of light going from air, if not vacuum, into this, right? So something like that. So first medium has to be air. And in terms of formula, it will be equal to c divided by velocity of light in ice. So since we know it is 1.31, this is 3 into 10 to the power of 8. It's a simple matter of calculation. We can find the velocity of light inside the ice. Okay, so it's something like that. Okay, that's it, right? So where do you guys have to? Okay, you have to start writing from here. So write all of it. We need all of this.